So I think we'll go ahead and get started. We have a lot to cover. My name is Nick Raboy, and I'm a developer advocate at Couchbase, which is a local NoSQL database company, which is going to be the NoSQL database that we use in this example. I have no intention of selling you anything, so let this be a learning example on how to develop full stack applications. So this is the only slide I'm going to show you. Everything is going to be from start to finish on developing an application, so it's going to be very code heavy. And feel free to stop me at any time to ask me a question. Just holler at me. So is that visible in the back? All good? All right, so what we're going to do is we're going to start by creating a Node.js application. This application is going to represent our API in this example, our backend. It's going to handle all of our communication with our database. After that, we're going to develop a front end using Angular, which is going to communicate with our Node.js backend that we create. The front end will never communicate directly with the database. It'll only communicate with our backend. So what I'm going to do is I'm going to create a new project on my desktop. So I'm just going to say make directory, and we'll call it project. And we'll navigate into it. Here, we're going to actually create a Node.js project. So I'm going to say npm init-y. And what that's going to do is it's going to create a package.json file in our project directory. And what we want to do is we want to add some dependencies. So we'll start with the framework that we're going to be using in this example. So we're going to be using Happy as our JavaScript framework. Another popular one is Express. But lately I've found that Happy is actually more suitable for developing APIs. It makes things a lot easier. So I'm going to say npm install happy -- save. What I'm also going to do is I'm going to install a tool called NodeMon, and this will allow us to live reload our application as I hit the save button. So that way I won't have to constantly start and stop the application. So I'm going to say npm install NodeMon, and this time it's going to be a developer dependency. So I'm going to do save dev. All right, so we have our two dependencies. I'm going to create a project file. This is going to be where all of our Node.js code goes. So I'm just going to say touch app.js. Doesn't really matter the name. And I'm going to open up that project in my editor of choice. So in my case, it's going to be Atom by GitHub. And I'll zoom in as well. So before we start developing our actual Node.js project, I want to go ahead and add our NodeMon script so that way we can make use of it. So inside the package.json file, what we want to do is we want to add another script. We'll call that start. And we'll reference the NodeMon path. So that's going to be in node modules and then NodeMon bin, so on and so forth. And I can save it. So with our script ready, we can start adding boilerplate code to our project. So I'm going to say var happy. Is that visible in the back, or should I zoom in? Zoom in? Better? Yeah? All right, perfect. So I'm going to include happy, which is what we downloaded. And I'm going to initialize it. So I'm going to say var server equals new happy.server. I'm going to define my connection information, so how I'm going to access my server. So I'm going to say server.connection. And I'm going to say that the host is going to be localhost, my local machine. I'm going to say that the port is going to be 3000. And I'm also going to specify that I'm going to allow for cross-origin resource sharing, because I'm going to be running my Angular application locally on a different port. If I don't do this, the browser-based JavaScript will complain at us for being on a different host or end port. So I'm going to say routes, be consistent here. And I'm going to say cores true. So now that I have that information established, I want to go ahead and start my server. So I'm going to say server.start. If there's an error, I'm going to catch it. And I'm going to say if error, then I'm going to say throw error. So it's just going to exit my application with that error. Otherwise, I'm going to say console.log, listening at, and then whatever server is. So server.info.uri. So let's go ahead and check out what it does real fast. Make sure that everything's in order. So I'm going to say npm start, which uses the nodemon script that we had set up. And then I'm going to say app.js. It says listening on port 3000 on localhost. So we don't have any routes as of right now. So what we're going to do is we're going to create a new route, which is going to represent each one of our API endpoints. And each one of those API endpoints is going to interact in some fashion with our database. So what I'm going to do is I'm going to say server.route. And I'm going to say method. This is going to be a get endpoint. The path for this get endpoint is just going to be the root of our application. And I'm going to define a handler. So what happens when we make it to this path? So I'm going to say request, response, and in this case, we're going to say response, hello world. And I'm going to save it. It should have automatically restarted in nodemon. So when I go to my web browser over here, and I'll zoom in, but I'm going to go localhost port 3000, and on the root it says hello world. So exactly what we've expected so far. So this is where we're going to get into some more interesting topics here. We're going to install some more dependencies. This time around, we're going to install the Couchbase dependency, which is a open source NoSQL database. It's a document database. So we're going to say npm install Couchbase -- save. And I'll clear that. I'll go ahead and start my nodemon again, npm start app.js. Before we go ahead and add our NoSQL logic to this app.js file, we need to go ahead and configure Couchbase a little bit. So I do have it running locally on my machine. I've zoomed in, so I'm going to log in. Zoom out a little bit. Is that still fairly visible in the back? Fair enough. So what we want to do is we want to go ahead and create a bucket. So in Couchbase, a bucket is where you store all of your NoSQL documents. You'll generally have one bucket for every application, and that one bucket can contain any number of different types of documents in it. So I do have a default. I'm just going to add a new one. I'm going to call this SVCC. I'm going to tell it how much RAM I want to allocate to it. 128 megabytes is more than enough for this example, and I'm going to add that bucket. So give it a second. All right, so it's added that bucket. It's got no documents in it. The next thing we want to do is we want to create a user role for it. So define who can access it and what they can do with it. So I'm going to go to security. I'm going to say add user. I'm going to go ahead and call it SVCC again. And I'm going to just give it a password 123456. And I'm going to define what I want it to be able to do. So for example, we're going to be doing reads, writes, and queries in this example. So what I want to do is I want to say, well, this is going to have data roles. I want to be able to read data from this bucket. So I'm going to say that this user account has access to that bucket for reading. I want to say that it has write access. And I want to say that it has various querying roles, which we'll see in a second. But I want to say that it will have delete. It'll have, it doesn't need insert for this example. It'll have select. And we'll save. And we could always come back and edit this as we go along. So I created the roles. And now we can go back into our code. And we'll bounce back and forth here. So somewhere in here we'll say var Couchbase equals require. And we'll say that we want to connect to our instance. So we'll say var cluster equals new Couchbase.cluster. We only have one node in this particular cluster, my localhost node. But if you are in a production environment, maybe you have 100 nodes, you'll specify whatever nodes you want in this list. And it could be one, it could be many. It's up to you. So we'll say Couchbase, localhost. We'll define which bucket that we want to open. So we'll say bucket equals cluster.openBucket. We called it SVCC. But we did also add an account to it. So what we want to say is we want to say cluster.authenticate. And we want to say SVCC and then our password. And we should be good to go at this point. So at this point, we can now start using our database within the application, just a few lines of code. And we can validate that our application is still running. It is. And we can worry about creating a new endpoint now. So let's go ahead and create another one. Server.route. Method. This method is going to be a, let's go ahead and say it's going to be a post. So this one, we plan to create data in our database, since as of right now, nothing exists in it. So we'll say post. We'll say our route, or our path is going to be, let's say it's person. So we're going to create a person in our database. And we're going to say our handler is going to be request and response again. So there's a few more things we need to do here. So first of all, let's go ahead and we need to add another library, another package. So in Couchbase, there's going to be document keys. This is how you determine what your document is. This could be something that is plain text. In our case, we want it to be a unique value. So we need to download some kind of unique value package. So we're going to say npm install uuid -- save. We'll go back into our application here. We'll go ahead and import that. And now we can generate unique values. So go back down here. To insert data, we're going to say bucket.insert. And we're going to use our unique key. So we're going to say uuid.v4. And we're going to define what data gets inserted here. So we're actually going to insert whatever payload the client has given to us. And we'll add validation in just a moment. But for now, we want to worry about just the payload. So request.payload. And this payload is the JSON body that gets sent in the post request. And then we want to say what happens on a success or an error. So we'll say error and result. So if there's an error, we're going to say return response, and we're going to say code is going to be error.code, and the message is going to be error.message. And I didn't just put error inside of the response because the error.message is actually a private variable and it won't show up in the response. And we're going to say code, it's going to be some kind of 500 error. So that way our client will recognize that something has gone wrong. If there wasn't an error, we can say response result. So if we tried to run this, we should be successful. So I'm going to go ahead and open up Postman, which is a tool that can be used for testing APIs. And I'll try to zoom in on this. Is that visible in the back? It's a different kind of zooming that I'm doing. So I'll go ahead and add some stuff. I'll just add Nick. And I'll go to send. And it returns something that wasn't an error. Cast value means success in our case. So we did a post request against localhost 3000, and then the person endpoint. So if we go to our database, we go to our buckets, we go to SVCC, we do have a new document now. So this is what we've just inserted. We created a unique ID as our document key, and we've just added one property. But we don't have any validation at this point in time. I could have added anything and everything in this case. So now we're going to be a little more specific. We're going to add some validation logic to our application. So there is a very nice package for that. It's part of Happy framework. They actually have something called Joy. So we're going to say npm install joy -- save. We're going to rerun our application here. We're going to go back up to the top and do another import. We're going to say var joy equals require. And now we're going to go into our route, and we're going to make use of this new package. So inside of our route for the post, we're going to add config. That's going to be an object. We're going to add validate, another object, and we're going to decide what we want to validate. So in this case, we want to validate the payloads of the request. So we can just say payload. I'll add a comma here so I don't forget. Inside the payload, I want to validate that, for one, I have a first name. I want it to be a string, and I want it to be required. I also want to have a last name. And I want to define a property that I don't want my user to be able to enter, but I want it to default to a value after the fact. So let's go ahead and give it a type. So I'm going to say joy.string forbidden. So it's not going to let the user type it in. And then I'm going to say the default value is going to be person. So as long as the user doesn't type it in, it's going to add a property to our payload and save it to our database as part of our values. I could add a timestamp. I could add a bunch more stuff. It could even be complex data. It could be another object in there if I wanted to. But for this case, it's all right if it's very flat. So I'll go back to our postman. I'll zoom in here. Go ahead and change this. And if I submit it, it should error at me. Yeah, so it said child last name is required. So let's go ahead and add that last name. I'm also going to add the type and see if it yells at me there. Send it. Yeah, so type is not allowed. So let's go ahead and remove it. Hit send. Looks good this time. Going back into our database here. It did in fact save it, and it did add that property that we had just added. So all is good so far. So I think we can move on to our next endpoint here. We've got some means to create new data here. So I'll go back. Let's go ahead and create another endpoint. This time it makes sense that maybe we want to get our data. So we're going to say server.route. The method is going to be get. Let's say path is going to be people, plural. And then we're going to have a handler. So same rules, kind of. We don't need to validate any user input because we really just want to get all data that follows our criteria. But we do want to make some changes. So to get more than one document in a NoSQL database, you're going to have indexes because you're going to have to index the properties. You can't. You can do a get for documents based on their key, but in this case, we're getting multiple documents and we might not know the key. So the first thing we want to do is we want to create an index in our database. So if I go to query, what I can do is I can enter a query to create an index. So I can say create primary index on SVCC. And now this is the most generic index that you can create. It's good for prototyping, terrible for production because it'll be very slow. In reality, you're going to want to create a specific index based on your querying needs. But this is fine for us since it's very small amount of data. So I'm going to run it. It seems to have worked out correctly. I can validate that it's there in my indexes page. Got a primary index there, looks great. What I can do before I start adding code to my Node.js application is I can go back to query, and I can try to query that information. So with Couchbase, even though that it's NoSQL and we're working with JSON data, we could actually use SQL queries in it. So I'm going to say select star from SVCC, where type equals person. Let's go ahead and execute it. Let's go ahead and view that data. It only returned 1 because the other document that I had created the first time didn't have a type. So it only found 1 document in that criteria, which was good. And we could do explain plans on it. We can do all kinds of stuff that you would see in a relational database just fine here. So let's go ahead and try to implement this in our Node.js application. So I'll go up and I'll go ahead and say somewhere in here var n1ql query equals Couchbase n1ql query to make it a little easier for us. I'll scroll back down into our new route that we're working on. I'm going to say var statement equals select, and I'm going to say star from SVCC where type equals person. So the same thing that we just saw in the dashboard, which is good. I'm gonna take it a step further to kind of narrow down our data here. I'm actually gonna say if I add SVCC dot star, it's gonna change our data a little bit, strip out some of that other stuff. So we're gonna do the same inside of our application. I'm gonna say var query equals n1ql query dot from string statement, and then I'm going to execute that query. So I'm going to say bucket dot query query, and then I'm going to say error result, and we're going to figure out what we want to do, which is essentially I'm going to copy and paste here. If there's an error, print out that error as an error response. Otherwise, let's go ahead and return whatever the result set was. So what I can do is I can actually go to my web browser here. I can go to localhost 3000/people because it's a GET request. And it returned that 1 record exactly as it should. So not so difficult so far. I'll zoom in. So let's go ahead and we'll create one more endpoint. We'll go ahead and create a delete endpoint. So we'll do another route. We're going to follow the same steps here. Method. We're going to say delete. We're going to say path. We're going to say person. And we're going to say handler. What we do want to do is we can either accept query parameters here, because what our goal is, we only want to delete 1 document. We're going to delete it based on its ID. We can accept a URL parameter, so it exists in the URL bar, or we can accept a query parameter. In this case, let's go ahead and just do a URL parameter, so we'll say ID. We're going to say var statement equals delete from SVCC, where we'll say meta. This is how you get the ID, because we didn't actually save the ID in the document itself, but we have access to that information in the meta information about the document. So ID equals $ID. And I'm doing $ID because we're setting ourselves up for a parameterized query. So just like in a relational database, if you go ahead and accept whatever the user has provided to you, you're going to end up getting hacked. So we want to definitely use parameterization as our protection. So we're going to say var query equals n1ql query from string statement, and we're going to go ahead and execute it. So query, we're going to say query. We're going to define our parameters here. So in this case, we have ID. We're stripping out the $sign in this particular location. And we're going to say request dot params.id. So whatever we've named it up here. And then we can say error result. And we'll just copy and paste again because it's going to be the same ordeal here. So in theory, if we hit this endpoint now, and we'll go ahead and make life easy here, we'll get the ID in our previous query because it wasn't being returned because it's in the meta. We can say meta.id, comma, and then whatever else is there. So we're going to refresh. We've got our ID here. I'm going to copy it, go back into my postman. We're going to change this to a delete request. We're going to add that ID onto the end and send it. Doesn't really matter what's in my post body. I'm not looking at that. Send it. Didn't return an error, so that's a good sign. And if I go back into the database or even refresh this page, it is gone. So the delete did in fact work. So we do have some endpoints now. So we probably want to think about creating a front end for this now. But before I skip ahead to the Angular stuff, does anyone have any questions up until now? Yes?
So what was the cast value that was returned?
So the cast value is a compare and swap value. It's what Couchbase uses to prevent any kind of overlap between edits and saves on keys.
So it's for consistency?
Yeah. Yes? Yeah, so yeah, good point there. So I did create a primary index, which is probably the worst kind of index that you can create. But what we could do is, let's zoom out a little bit first. All right, so what we could do is we could do something like this. So we could do create index, let's call it by type on SVCC. And we'll define the type because in our query we're using the where clause and we're using type. So if I wanted to, this should work. Yeah, so if I go to indexes, I now have a by type, and if I queried using that query now, it would now use this index instead of the primary index, which would be significantly faster. The primary index should only be used for prototyping purposes. Yes?
Do I have to explicitly go to the UI and create it?
No, so you could do that through code. There's also a command line interface that you can use to do that. It's however you choose to do it.
To create a table, as in I'm assuming bucket is analogous to a table.
Sort of. You could sort of think of it that way, but not quite.
So can I create, because when I used to use MongoDB,
Yeah.
there's this thing called Mongoose that creates, through which it directly creates a table. Like when I insert my element into a table, the table gets generated. So is there something like that, or do I need to create a table first before insertion?
You'll have to create it first because you'll also have to define your roles on it, your user roles, and potentially an index as well. But you don't have to use the admin interface for that. You could use the CLI as well. All right, yeah, I'll move along then if no further questions on the back end stuff. So what we want to do is I'll leave this running. I'll open up a new tab, and I'll navigate to my desktop here, and I'll create a new project. So I do have the Angular CLI installed. This is the latest version of Angular. If you wanted to install the Angular CLI, you would say npm install Angular/CLI, G for global. But I already have it installed. What I'm going to say is I'm going to say ng new, and I'm going to call it Angular. And it's creating a project on my desktop now. Takes a variable amount of time depending on the internet connection. All right. So what I'm going to do now is I'm going to actually close out of that, and I'm going to just open up the Angular project. Oops. So I do have my project. This, I know it's a little small on the left. I don't know how to zoom in on the toolbar here. But it does create some boilerplate code for us. So what we're going to do is we're going to spend most of our time in the source directory and then the app directory. So by default, if I go ahead and run this, I'll say ng serve. It's going to serve it on port 4200 in a second. Let's see if it's running. So this is what we would get out of the box with Angular. So we're gonna change it significantly to start working with our data that we had just created with our backend. So the first step here is we want to create a page that we can use for listing out the people in our database. So let's go ahead and we'll say ng g for generate component, and we'll call this people. And what that did was it created a file and a folder inside of our app directory called people, and that includes a TypeScript file, an HTML file, and a test file. We're going to spend all of our time in the TypeScript file and the HTML file. So Angular does use TypeScript, which is just a superset of JavaScript. It'll be very familiar to you if you know JavaScript, but it is a type language, and it will yell at you if you try to compile bad code. So let's go ahead and do a few more kind of bootstrapping things to our application. So the next thing we want to do is we want to go to app module. And because we're creating a multi-page application, we need to use some kind of router. So we need to import some Angular dependencies. So we're going to say import router module from Angular/router. And Angular has a ton of dependencies to do pretty much anything, but once they're there, it's very easy to use. So we've added the router dependency, and now we need to define our routes. So what we can say is var routes, and this is an array, and we can say for one route, we're going to give it a path, kind of like what we did for our backend. This path is going to be an empty string, which represents our default route. So the first page that shows up when we start our application. And we're going to link it to a particular component. So the component we're linking it to is the people component that we had just created, and that was already imported into this file for us. I'll save it. I'll also add it to the imports. So I'll say router module, and then router module.forRoute, and this is going to be routes. So this is all Angular kind of preparation work. So if I go to my app component.html file, which was that file that we saw on the screen here, we need to tell this HTML file that all of our traffic really is going to be redirected to any kind of child routes in our application. So what we want to do is we can really wipe all this out, and we can say router outlet. So if we went back, we can see that it's now kind of redirecting stuff into our people component. If I wanted to, I could add more stuff here. And that will show up as well. But really what it's doing is it's rendering our HTML from our people component here. So now let's worry about listing out that data in our database. So what we want to do is we need to add a few more dependencies. So we're going to need to do HTTP requests against our Node.js application. So what we'll have to do is we'll have to import the Angular HTTP module. So going back into our app modules file, we'll add another module here, import HTTP module from Angular. We'll add it to our list here of imports. We'll save it. And now hopefully we can go to people component TypeScript and start adding that consumption logic. So we'll go import HTTP from Angular HTTP, different from our HTTP module. We'll go to our constructor. We'll have to inject it into our constructor for usage in our application. So we'll say private HTTP. And when the application loads, we want to issue an HTTP request. So we define our variables inside the constructor. We do any kind of loading inside of the ng on init, which fires after the constructor method. So we'll say this.http, which is what we had just injected. We'll say get. So we're hitting our get endpoint. It's going to be HTTP localhost on port 3000, and it's going to be our people endpoint. So HTTP and pretty much most of Angular uses RxJS for observables, which is what this is going to return. So we need a way to subscribe and work with those observables. So we have to import RxJS. So what we can do is, so we make this request. Now we need to figure out what we want to do with the response. So we're going to say map. So we have the result. We want to transform it. So the map operator transforms our response into some other format. So we're transforming it into JSON. And we can do a whole lot of other stuff, but we're going to try to keep it a little simple here. We're going to subscribe. And we're going to say result. And we're going to figure out what we want to do with that result of the now transformed HTTP request. So we don't have anything to store it in, so we need to create a variable for us. So we want to say public. We want to say people. This is going to be a type of array because that's what our particular endpoint returns is an array of objects. So we're going to say any because we're not going to declare any kind of interfaces here for our objects. We're going to initialize that array inside of our constructor. We're going to say this.people equals some empty array. And then we're going to say this.people equals result. And I didn't just initialize it in here because it's asynchronous, and if we try to access it before this is finished, Angular might throw some errors at us. So we do definitely want to initialize it as an empty array first. So we'll go ahead and save that. We'll go back into our HTML file, wrong HTML file. We'll go to people component HTML, and we'll create a list to list our data in. So what we want to do is we want to loop through that public variable, and we made it public so that way we can access it from our UI. If it was private, it would not be accessible from our HTML. So we're going to say ng4 equals let person of people, so people being our public variable. And what we can do is we can say it's person now, dot first name, because first name should exist when we do our inserts. I don't think we have any data in there right now because we deleted it. And what we can do is we can say person dot last name. And bring it down to a new line here. So let's go ahead and create some data and see if we can get it to work. So we'll go back to person. We'll go ahead and insert some data here. It looks fine so far. If I go ahead and refresh my application, so it now pulled that data that I had inserted into my database by using the backend API. So we're going to create another endpoint for creating data. Almost out of time, but we'll see how far we get. So what we want to do is we want to create another page. So we'll say ngg component. We'll call this one create. It created another directory inside of our app folder called create. Same set of files. A TS file and an HTML file is what we're going to care about. But before we do that, let's update our router. So it's added in our app.module file already. But let's go ahead and say that our new path here for this next component is going to be create. And this is create component. We can save that. This create component will have a form on it, which will be bound to our TypeScript, so we will need to worry about importing another module. So this one will be import forms module. I'm going to import it in the import section too. We can go back into our people.html file, and let's go ahead and add a link that'll take us to that newly created route. So we can say A, and then we'll say router link. This is how Angular can navigate between routes. And we're going to say, we called it create, right? So if I save it, and I go back to my page here, and I click this, it took us to the create works, just exactly as it should. We don't have anything there, but at least it navigated us away. So with that said, we can go to our HTML file. We can add a form here. It's not going to be attractive. You could add Bootstrap or whatever foundation, whatever you wanted here. But what we would do is we would say, let's go ahead and have an input. That'll be type text. Oops. We have, we'll close that off. We'll have a placeholder. First name. And we need to save it. It's there. It's good. So we go to create.ts. We need to figure out what we're going to bind this form to. We don't have anything to bind to it. Our TypeScript file is very generic as of right now. So we'll create a variable in here. We'll say public. We'll call it input. We'll give it a type of any. Inside of our constructor, we'll initialize it. So we'll say this dot input equals, and then whatever our form elements will be. So in this case, we'll have first name. This will be empty. We'll have a last name. And I think that's all we required was the first name and last name. So if I went back to our create HTML file, I'll give it a name. We'll call it first name. And we'll say ng model equals input dot first name. So this is referencing that public input variable and the first name property. I'll clone this. I'll just add a BR here. I'll say last name, input last name, and we'll add just a simple button for saving. Looks all right. We've got a very simple form here. We can go back into our TypeScript. What we want to do is we want to figure out what we're going to do with the save. So we'll create a save method. We'll import HTTP because we'll be making an HTTP request. We'll import RX. And we won't be doing anything in the ng on init because we don't need to populate anything already. So in the event of a save, we can say this. We didn't inject HTTP. So private HTTP. This dot HTTP dot post. But there's a little more to it, unfortunately, for post requests than there were GET requests. So we also have to define some header information. Because by default, it's going to try to send it as form URL encoded. We want to send it as JSON. So we do need to include headers and request options. So in here, we can say var headers equal new headers, content type, application slash JSON. var options equals new request options. Headers equals headers. And now we can get down to business here. So we can do HTTP localhost person. We have an object here, but we have to send a string as our body. So what we have to do is we have to serialize that JSON as a string before we can send it. And then the server will automatically know that it's JSON because we're sending it as such as the content type. So we're going to say json.stringify, this.input, and then finally options as our request options. So if we want to start manipulating our results, we're going to say map results equals results.json, and then finally subscribe. So when we're successful, what we actually want to do is we want to navigate backwards to the previous page. And that can be done through another import in Angular. But we're going to say import location from Angular/common. We're going to inject it because it's a service. And what we can do is we can say this.location.back. We can give it a try and let's see if this works out because we are, I think, out of time. So let's go ahead and go back. We'll start from fresh here. Save it. It didn't do anything because we didn't link up that button. That button doesn't do anything yet. So if we go back into our HTML, we can say click on the click event. We're going to say call that public save function from our TypeScript file. So let's go ahead and try it again. Save it. It took us back. It didn't show us automatically right there that it is, but if I refresh, it is there. And the reason why it didn't show us it as soon as we hit back was because our index hasn't updated yet. So if we went back into our Node.js code, we can define our consistency in Couchbase. So we can say, you know what? Don't give me any results back until the index has refreshed. And I won't go over that now because we are out of time, but this could be easily fixed. And that's kind of the gist of creating that backend. It didn't take us that long. We've spent more time with Angular than anything, but that's part of the stack, and you could easily take this to mobile as well. Any questions? No, that was a lot to take in. Yes?
Any particular reason you chose Happy over Express?
So I used to use Express for a long time, and there's nothing wrong with Express, but it felt like it takes a lot to do anything really in Express. There's tons of middleware that you need, and I don't know, I felt like Happy was a lot less work overall. It's just personal preference. Thanks.